Hello and welcome to the fourth video of the onboarding video series to the Eclipse Dataspace Connector. My name is Paul and today we're going to talk about a few of the core classes of the core items that make up the EDC connector. First and foremost, let's talk about the vault. A vault is something that can store secrets securely. So say you want to maintain passwords or access credentials for your S3 buckets or something, you would put that in the vault. So the vault looks like that. It can store secrets, it can resolve secrets, and it can delete secrets. So that's the key features that a vault has. Of course, we have default implementations for it. We have the null vault, which gets loaded if no actual implementation is found. That doesn't do anything. It basically indicates, hey, you can't really store anything in the null vault because it can't do it. And then there is a file system vault, which you can always use. That's basically, it's unsecure. What that is a file-backed in-memory implementation. So it basically loads everything from a file into memory and then persists it back out into the file. You should be aware that that is not for production use, it's just for development. In actual production environments, you would probably want to use something different like an Azure Vault. That's also one of the vaults that we have. So that in fact stores your secrets in an Azure Vault. In order for that to do that, you need to supply the implementation with a client ID, with a secret or a certificate, tenant ID, all this good stuff. You can find this here in the Azure Vault extension. Again, how this works is you write an extension that contains an extension class. What this extension then does is it initializes or instantiates the vault and then binds it to the vault interface. So that's basically what a vault is. Right, so next up we have a monitor. The reason a monitor is essentially a logger. You might know this from Log4j or SLF4j or any other logging framework that you have used in the past. We wanted to not introduce dependencies into the core of the connector. That's why we have the monitor here, which is our entry point into the entire logging topic. You could then bind your, Logstash logger that forwards logs to Logstash or your Azure logger. However, we're always using the monitor. You implement that interface and then you can forward your log lines to that logger. There is also a default implementation, which is the console logger. Console monitor, sorry. That just puts out stuff on the command line. You might want to add your own console logger, especially if you wanted to supply more elaborate formats or more log levels or whatever, or log tags, whatever comes to mind, so you can extend that. Same thing. You write your own extension, put the logger in, and bind it to your launcher in the launcher's build file, and you're good to go. So next on our list is the Transfer Process Manager, and that's possibly one of the core classes, one of the most important classes of a connector, because what that does, it implements the Transfer Process Manager interface, But what that actually does, the default implementation for it is a state machine. Let's take a look at the implementation. Oh, sorry. So when a client initiates a transfer request, basically client says to the provider, hey, please give me data. The way this works is this trickles through a state machine, because like I alluded to before, we want the stuff to be resistant and we want it to be persistent. So a transfer request must be persisted into a database. So the transfer process manager basically handles all that. A request comes in and the request is in the initial state. Then potentially cloud resources get provisioned. That can take some time. Therefore, the transfer process manager is essentially a runnable that ticks over every few seconds. In each iteration, it checks in which transfer processes are in which state and tries to advance them. Like say we have a few transfer processes in initial, then it might advance them to the provisioning state and at the same time try to provision these resources. Or say if a transfer process is ongoing because data is being transmitted, then the transfer process manager checks in every cycle whether the transfer process has already completed, for example, because the file is already there. So these are a few states that a transfer process manager can be in. Let's take a look at one of these. For example, maybe let's check the one of the first ones. Yeah, so when a request comes in, it is in the initial state. So the transfer process manager enters the provision initial process method and gets from its store, which could be a database, all the transfer processes which are in the initial state. In our example, that would be just one. Then for each transfer process, the transfer process manager tries to generate the manifest. The manifest is essentially a list of resources that need to be provisioned. If no resources need to be provisioned because we are doing, for example, a simple file transfer, then the data request should have the managed resources flag set to false. If that is set to true, which means a resource must be provisioned, the transfer process manager goes ahead and tries to generate the manifest. The transfer process is then in the provisioning state, which means that cloud resources are in the process of being created. The transfer process manager will also delegate out to other objects like the provision manager. Say a request comes in and the client wants data to be stored in an AWS bucket. That would mean that here the manifest generator generates the manifest, which includes one S3 bucket, and then the manifest gets handed to the provision manager, which goes ahead and then provisions that S3 bucket. The provision manager is one of the things that a transfer process manager can delegate out to. The state is advanced and that stage of tasks is completed. Now the provision manager who does the provisioning of cloud resources or any other type of resources will then internally advance the state to provisioned, which is the next state that the transfer process manager or the next state that the transfer process manager checks. Basically in the next cycle, our transfer request will be in the provision state, and the transfer process manager will then try and initiate the data flow. So what that does is, if we're on the consumer, that's pretty easy because we'll just send out the request via IDS to the receiver of the transfer process. Until this time, the data provider has not received any information or has not yet been contacted. So until the provisioned state, or to be precise, the requested state, the providing connector does not know of any data request. This is what this state does. So the consumer provisions the resource where he wants the data to be put, for example, an S3 bucket, and then goes out and sends the request over to the provider. If we're running on a provider connector, that means that we can initiate the data transfer. That is done by delegating out to yet another class, which is the data flow manager. We'll take a look at these classes in more detail in a minute. So basically what the transfer process manager does is it tells the data flow manager, hey, here's a data request, please take care of it. Then there are a few other methods here, like check if a transfer is completed. They are pretty self-explanatory, or check if something has already been provisioned, or check check any deep provisioning requests. We'll talk about that in more detail in a later video. For now, let's just remember that the transfer process manager basically iterates through a list of transfer requests. Each transfer request state, or each transfer process state, contains a few transfer requests and then tries to advance their states. So it's essentially a state machine. Let's take a look at the provision manager. And let's just open up the default implementation for that, because that's going to tell us more about it. So if a transfer process requires a resource to be provisioned, like for example an S3 bucket, the provision manager will take that process and iterate through all the resource definitions, all the singular resources that the manifest contains, and try and find a provisioner for that resource definition. So what you want to do, you want to write a provisioner that can create S3 buckets in Amazon, in AWS. Or if you are on an Azure, you want a provisioner that can create blob stores or data lakes or blob containers in Azure. So for each type of resource definition, you will need your own provisioner. That needs to be registered, but essentially the provision manager matches a resource definition to its provisioner. And the provisioner, we can take a look at that too. That's again an interface, and let's take a look at the S3 provisioner. The S3 bucket provisioner. That doesn't do a lot. It basically has 4 methods, which is the initialize. It receives the provision context. Let's just take that for face value for a moment. It has a method to determine whether it can actually provision the resource, and it can deprovision the resource. That's what the provision manager uses to determine which provisioner is right for which resource definition. And then it has a provision method. In this case, that again goes out to another class, to another object, because provisioning usually takes some time, and the S3 SDK offers an asynchronous client. So we delegated that out to a provision pipeline, because what happens behind the scenes is a temporary user is created with a temporary role, and that temporary user and role get temporary write access to that bucket that has just been created. These credentials are then sent back to the provider, and the provider can use them to store data inside the bucket. So that's what the provision manager actually does. It matches resource definition and the correct provisioner. You don't need to do it that complex. For a simpler example, we can also look at the object provisioner, object storage provisioner. That's kind of the same thing in Azure. That does the provisioning right inside the provisioner and does not delegate out to a pipeline because it's much more straightforward. You basically create an object container and temporary SAS credentials. That's it. What the provisioner also does is it calls back to the provision context. Remember when we receive the provision context in the initialize method, that's actually how the provisioner can then communicate back to the provision manager that the provisioning has finished, and the resource that results from the provisioning process and the secret token, which can then be sent back to the providing connector. So we have a resource definition, which is basically the wish or what we want to provision. So we want to provision an S3 bucket. Therefore, we have an S3 bucket resource definition, and the result is then a a provisioned resource. The reason why this becomes necessary is because sometimes and in some environments the provisioned resource contains additional information like URLs. A bucket might have a URL which is only known after the bucket has been provisioned, or the name of the bucket is the desired name is not available, therefore the name becomes -1, then that would be stored inside the provisioned resource. That's why this duality exists. The same thing we have for S3, so we have the S3 provision pipeline. So basically here we receive in the in this method, which is the last step, we compose the provisioned resource, we obtain the secret token, and we call back to the provision context that the resource is finished, and that's the secret token to access it. So this is how the provisioner and the resource definition works. So we have a manifest. And the manifest is nothing more but a list of resource definitions. A resource definition. A resource definition is a description of a resource. An S3 bucket, a blob store, I don't know, a directory on an FTP server, could be a database table, a Kafka topic, whatever. That's a provision. That's a resource definition. And like I said, on the other side, we have a provisioned data destination resource or a provisioned resource, and that's the actual representation of the instance of that resource, because that might carry additional information. Right, so let's close all the tabs so that we don't get confused by them, and let's move back to the transfer process manager impl. And before we saw the data flow controller, data flow manager. So first we have the provisioning process, which is now complete. The provisioner, the provision manager have done their job, and the data transfer can now start. What the transfer process manager impl does, or it delegates out to the data flow manager, which in turn is pretty similar to the provision manager. And that's the interface. So let's open up the default implementation. That maintains a list of data flow controllers, much like the provisioners. And what the data flow manager now does is it matches data requests to data flow controllers. So if for your data request a data flow controller exists, then you're good to go. And again, this is determined by the can handle method. Let's just open up one of the simpler ones, maybe the transfer file flow controller. That can handle every data request where the destination type is file, which means if a data request is such that the destination is file, then our file transfer flow controller can handle it. So let's assume at this point we have a data request where one file should get copied to another file. Then our file transfer flow controller will receive that request. Does a bunch of logging and error checking, and then it updates the process. So the data flow controller has a few methods. That's the can handle, which means can that flow controller deal with that data request? In this case, and then it has the initiate flow method. So data transfers are intended to be, again, asynchronous. In this simple example, what's happening is it's just a simple file copy process, basically a CP. In a shell, you would issue a CP command. Here it is nothing more, just a bit more complex and with a bit of error checking. But that's essentially what it is. But it doesn't have to be like that. The data flow controller might also delegate out to, I don't know, an Azure function or Apache NiFi or another third-party tool that does the actual copying of the file. So the file transfer flow controller is intended to only initiate the data flow. Of course, it can also actually perform the data transfer, but in many cases you'll want that in a batch queue or something, or a third-party tool, some big data pipeline or what have you, a streaming service. Then that's why this is called initiate, because it just initiates the data flow. So these are the key features of a connector. Let's quickly talk about what else is there. We also have policies. So we have a policy, and the policy is basically either permissions or prohibitions or obligations, something you can do, something you cannot do, and something you must do. So your data transfer can have policies attached to it. For example, you have a data asset, a file or a stream, which you only allow to be transferred within the European Union. Then you could write a policy that actually specifies that. This is then negotiated during the contract negotiation phase, which we'll talk about in a separate video. But that's essentially what a policy is. A policy is either something you can do, something you cannot do, or something you must do. So just to recap real quick, we have the vault, which is a secure store for secrets. We have a monitor, which is essentially a logger. We have the transfer process manager, which is essentially a state machine, a provisioner, which creates resources, a data flow controller, which actually handles the data transfer. We have policies that restrict data transfer. So that's these are the most key features of a connector. So I hope you enjoyed it. If you did, check back for the next video, which will talk about the role of IDS, and I'll see you then.